it connects the gearbox to the final drive. So what is the final drive here? The final drive is nothing but it is the differential which divides the power to both the wheels equally. Okay, so this shaft, the main function of this shaft is it has to transfer the power from the gearbox to the differential. So this is the differential. So we'll take this sketch as reference. Okay, we will take this sketch as a reference. This is the actual pictorial view, okay, of a differential, propeller shaft. You can see the propeller shaft here. Okay, its main function is, so this is the end of the gearbox. From the gearbox, the power has to be shifted to the differential. So this is the actual differential part. Okay. So the propeller shaft is a shaft that transmits power from the gearbox to the differential. One end of the propeller shaft is connected to the transmission shaft. Okay. So this is the transmission shaft, that is the gearbox shaft. One end is connected to the gearbox shaft and other end is connected to the differential shaft. Okay, you can see two ends are there. One end will be connected to the differential shaft, one end will be connected to the gearbox. So the one end to the differential gearbox, one end to the transmission gearbox. So these two are called as universal joints. Okay, why you cannot use regular bearings or joints? Why? Because you can see, okay, there is an angle of approximately 20 degrees between the shafts. If these two shafts are in line, okay, so this shaft, one second, I'll draw a line so that you can understand. So this is the axis of the differential shaft, okay, differential gearbox. This is the axis of the transmission gearbox. Okay, so whenever you take an angle between these two, okay, an approximate angle of 20 degrees will be there, plus or minus 2 or 3 degrees. Plus, this is not a rigid frame. So it will be connected to the back axle. When a truck is moving, you can just observe this will be connected on a back axle. This back axle will be moving up and down in the humps and vibration points wherever potholes are there. So if you use a rigid shaft here, immediately it will break whenever this moves up and down. And also the rigid shaft cannot transmit the power. If both the axes are same, you can use a direct rigid shaft through regular bearings. Okay, there is an angle first issue and this end is fixed. No doubt this cannot move up and down. Okay, but this end will be constantly moving up and down. So the C and B are the universal joints. They can rotate in any direction. Whenever this moves up and down, the up and down moment will be taken care by the universal joints. The propeller shaft transmits the rotary motion of the transmission shaft to the ultimately to the wheels. From the differential, it will be transmitted to the wheels. Right. So this is about the propeller shaft. The main function is you cannot use a regular shaft. Okay. Why? Because they are the axis is not same. Usually an angle of 20 degrees will be there. First thing, and the second end of the shaft is not fixed. It will be keep on moving up and down. Okay. So this is about the propeller shaft. Okay, so same thing I have explained here. The definition of propeller shaft I have given, commonly used definition. Whatever functions I have explained, the same functions are there. Okay. So what are the construction details of the propeller shaft? Tubular propeller shaft is generally used. So whatever in the sketch we have seen here, okay, is a tubular propeller shaft. Okay, it has the capacity of varying the length also, like piston cylinder arrangement. Okay, whenever this moves extremely in a very big pothole, the shaft should not break because of the tensile stress. So both the ends will be moved apart. So little bit expansion will be there. Whenever it comes back to the position, it adjusts. Okay. So usually a tubular structure like this will be used for the propeller shaft. Okay. So why tubular propeller shafts are commonly used? Because its weight will be less. Okay. It has very rare chances of misalignment. It can resist the misalignment. As I told you, whenever extreme change in length is there because of the tensile stress, okay, so it will it will act like a piston cylinder arrangement. It will come back to its original position. Okay. It has a very good torsional strength also. It can withstand torsional loads, okay, and it provides lesser resistance to change of angular speed. Okay. when hook type coupling is used. Okay, angular velocity, whenever there is a change in the angular velocity of the shaft omega, okay, it provides a very less resistance. Easily it can accommodate the angular velocity variation. So these are some of the advantages. So usually tubular structure itself is used because of this. Okay, you cannot use a square or triangular sections. Okay. Propeller shaft is running faster when overdrive is used when you go on a top gear, and hence it should be as per the design specification. Okay. So next is the universal joint. Okay, I have added one more sketch here. You can see just for your understanding purpose. Okay, you can see these are the universal joints. This is the propeller shaft. Okay. So here it is at a different angle. Here differential gearbox is at a different angle. As I told you, it is a tubular section. This can move in and out to withstand the tensile stress. Okay. So this is called as an universal joint. I just clearly explained why universal joints are used. First point is both the axes are not same. There will be minimum of 20-degree shift. Second is the second end, whatever you can see, this end is not rigidly fixed. It will be keep on moving up and down. When there is a bump, suddenly it moves up, then it comes down. So that should be taken care of. So you cannot use a regular collar here. So you have to use a universal joint. Okay. So universal joint, usually it is called as a U joint or a hooks joint or a universal coupling. Okay. It is a type of coupling where rigid rod that allows the rod to bend in any direction. So it can bend in or rotate in any direction. Okay. It is usually useful for transmitting of rotary motion. Okay. So up to 20 degrees it can take care. When there is an axis misalignment of 20 degrees, it can work comfortably without any issues. Okay. It is a flexible connection between two rigid shafts at an angle with each other. As I told you, the axes are not same. Both the axes are at an angle of 20 degrees. These joints allow angular movement between two shafts and transmits power at an angle. Okay. In automobile, universal joints are used not only to permit power transmission, okay, from horizontal shaft output to the propeller shaft. It usually the main advantage is it allows the change of angle due to movement of rear axle up and down. This is what I explained. Okay, so the differential gearbox will be mounted on the rear axle. Rear axle in the next topic we will be studying in detail. Okay, so the rear axle, whenever there is a hump or a pothole, it will be moving up and down. So one end of the shaft will be fixed, whereas other will be constantly moving up and down. So in such cases, these joints are very much useful for transmission of power without any failure. Okay, so this shows a sketch of a propeller, universal joint. Please make a note of the second one. So this sketch, you make a note. You can see here. So this is one end of the yoke. This is the second end. Yeah. So A and B are two joints, and there is a cross in between. So whatever the moment is there, both the yokes move accordingly, and it will adjust so that the joint will never fail. Whenever there is a huge hump, also there will be no question of any issues. So please make a note of the sketch. So this is about the universal joint. So there are 4 marks questions usually. They'll ask you need to explain the functions. Universal joint and propeller shaft for 8 marks like that. So you have to draw a sketch and briefly explain. Next important component is the differential. So we have discussed about the clutch, gearbox. After the gearbox, next comes is the joint, universal joint, then propeller shaft, then again one more universal joint will be there. After that, differential will come. Okay. So just before moving ahead, once again we'll go through this sketch briefly. Okay. So just go through this sketch. We have completed the discussion about this part. So engine anyway in the first module itself we had completed in the entire, this is called as the entire power train. Okay, so engine we have completed, clutch and types of clutch we have completed, transmission system we have completed. After transmission system we have a U joints, 2 U joints are there. So universal joints we have discussed, propeller shaft we have discussed. The next important component is the differential. After the differential, the last one will be the axle, rear axle, on which the differential and wheels will be mounted. Okay. Now we will go ahead with the differential. After that, we will discuss about the rear axle. Okay. Okay. Just make a note of the sketch. We will start discussing about the differential. Okay. Take down the sketch. It's a differential. With the help of an animation sketch, I'll explain you clearly. But for the exam point of view, you have to practice the sketch. Please make it fast. First, we will discuss why this differential is required. What is the function of this differential? What happens if this differential is not there? So it is a common experience that when an automobile is in a curve, in a bend, the distance traveled by the outside wheel will be always greater than that of a distance traveled by the inner wheel. Okay, just think of, say for example, you are taking a left curve turn. There is a huge turn. Okay. So what happens? The wheel, the front wheel, which is in the driver's side, okay, will have a longer term, and the co-driver side wheel will have a shorter term. Suppose if you are taking in the opposite direction, instead of left, you are taking a right curve, then co-driver side wheel will have a longer turn, and the driver side will have a shorter term. Is it correct? So this will be a common observation that we do. Okay. If the wheels are mounted on a dead axle means it cannot accommodate any curves turn like this. It will be fixed with the help of a fixed gear system. Okay. So gear, with a bevel gear, directly if you fix and divide the power, it is a dead gear system. Okay. If a dead gear system is there, it cannot accommodate the change in radius like this. Okay. So for front wheels, there will not be a problem. Why? Because the steering mechanism takes care of it. But for the rear wheels, okay, when both the wheels are not turning on the same radii, this differential gearbox is very much helpful. It gives lesser rotation to the inner wheels and more rotation to the outer wheels. So the one new thing that we have discussed here is differential not only divides the power equally to two shafts, but it also takes care of the change in rotation required in curve movements. Okay. So based on the curve, it is moving, so it will take care. So inner wheels will always get lesser rotation relatively, and outer wheels get more rotation, so that vehicle will be stable. So this is the main function of differential. See, otherwise, only for the distribution of power to the two shafts, you can use a bevel gears. Simple, two bevel gears and one straight gear. So obviously, it will be divided equally. But if the vehicle is moving on a straight road, okay, this bevel gear mechanism can help. Okay. But if it is move, whenever a curve comes, automatically this bevel gear mechanism will fail because of stress. Okay. So because one of the shaft will be taking a longer turn, it cannot give so much of power. So there will be slipping in gears, and finally it fails again whenever there is a huge curve is there. So in order to accommodate that, a proper mechanism called as differential is used. Okay, I hope you have understood why a separate gearbox is used for distribution of power. When you come back to college, you can just see the Toyota Center of Excellence. A cut section of differential gearbox is there. Okay, when you see that, you get a clear idea why not two simple gears, why it is used. Okay. So now you just go through this animation. Okay, the first case, input torque is applied to the ring gear, which is in blue color. So this is the ring gear. Okay, so here your propeller shaft, this is the propeller shaft end. Okay, so to this ring gear, the propeller shaft will give the power, right, which turns the entire carrier. So this entire mechanism will be turning. Okay, so because of that, this red gear also gets the torque, so that this green as well as yellow gears also get a torque, so that there will be a equal movement. Okay, you can see the same thing is mentioned here. Input torque is applied to the ring gear, which is blue in color. Okay, providing torque to both the side gears. So both the side gears will get the power directly from the input shaft. Okay, which in turn may drive the left and right wheel. So this will drive the left wheel, this will drive the right wheel. So okay, if the resistance at the both wheels is equal, okay, the planet gear does not rotate. So if the vehicle is moving on a straight road, this is called as a planet additional gear. Okay, this will not rotate. Whatever power is coming, that will be taken as two halves equally. One of them will be given to this red shaft, other will be given to the yellow shaft. Suppose, okay, you are encountering a, you are moving through a curve. Then what happens is this green color, whatever gear you can see. Okay, this is called as planet gear. Based on the resistance, this immediately gets activated. Okay, so the, say for example, you are undergoing a right curve. You are moving in this direction. Once again, I'll demonstrate here. So you are moving in this direction. So what happens? This is your left wheel and this is your right wheel. Okay, this requires extra rotation, whereas this requires very lesser rotation. So this shaft will have more resistance and this shaft will have lesser resistance. Okay, so because of the lesser resistance, freewheeling on the longer term, okay, this will get higher rpm, whereas because of very high resistance to movement, because this is the inner wheel, okay, this will get a lower rpm. So this planet gear is responsible for, okay, maintaining the big balance of the vehicle in the curves. Suppose if you are moving in the right, opposite curve, say for example, you are undergoing a left curve like this. Okay, you are undergoing a left curve like this, then the mechanism will be opposite. This will be on a freewheeling motion. It will get higher RPM because of lower resistance. This will be having higher resistance. It will get a lower RPM depending on the curve you are turning. So this is how a differential gearbox works.